Can you guys see this?
Yes.
Yes.
Glorious. All
Yep.
right. Cool. There is going to be a lot of layers to this lecture, but this is an extremely fundamental lecture. And I'm going to try and point out things to you that maybe not be, I don't want to say pertinent, but anchored in core to anything with a grade with quizzes and tests and assignments. Um, because I try to give as much leeway as to the actual coding process as possible. But it's more important if you decide, hey, I like this Python thing or I like this programming thing, and I want to keep moving with this. And I'll try to tell you, point out any similarities between other languages. I'm a huge advocate for knowing a breadth of languages. I'm there's some that are certainly more that I find more agreeable than others, like Java. God, I cannot stand Java. Anyway, it's neither here nor there. But the more languages you know, the more you're going to see similarities between the languages. And one of the best things about learning Python is that when you start to understand, the syntax may change, but the thought process behind Python and the execution of Python code is universal to almost all modern languages. Any object-oriented programming language, and we'll get into what that means later on in the course, but basically, um, programming languages that implement classes and a process called inheritance. Um, Everything you're going to be learning in this course will translate with minor linguistic changes in the other languages. And when we start talking about strings, especially strings, because using strings is as a data medium is universal. I was just having a really good conversation with a buddy of mine who's also a full stack web developer, and we were talking about. I was talking about this lecture, and I was talking about how fundamental strings are. And he says, "Yeah, when I'm building APIs, which are the connecting tissue between a server and an endpoint for a user to connect to, the rules that govern strings that he felt he didn't know early in his programming career came back to bite him in the butt, but the fundamentals are ever present. So it was really cool to have a conversation with him in the industry talking about exactly this. So I'll try to point out things that I think are important if you want to continue this programming journey, which I hope you do, by the way, because it's only getting cooler. I mean, uh, AI and machine learning. I'm just now starting to get into to machine vision and just the things that are capable that you can do from your home now, or things that were only even possible in a lab 20, 30 years ago. So I hope you find this kind of inspiring. So let's talk a little bit about what we're going to learn tonight. We're going to go back and we're going to talk about something called comments. Spend one page on that. We're going to talk about strings on more than one lines, also known as multi-line strings. We're going to talk about an interesting concept called arrays. Um, our strings being arrays, and we'll get more into what that means in a second. And then we'll talk about concatenation again. We spent some time talking about it last week, the formatting of output from strings, and then string methods, which are, well, we'll get into that in just a moment. Any questions on any of this content before we jump in, or more importantly, anything that you need a quick refresher from previously before we get into this? Okay. If you guys have anything that crops up in your mind, just let me know, and we'll take a quick segue and figure out uh, how we can better understand something. So let me know. Okay. All right. So first thing we're going to talk about are comments. So this screen that you're seeing right here might look altogether foreign to you as we start to make the transition from the command line interpreter to an actual IDE, an actual development environment. You'll start to see that it gets a little more colorful, maybe a little intimidating, but I hope more useful to you. And we'll spend an entire video. I won't bog down a lecture with it, but I'll give a full rundown of what the modern IDE looks like. So that's what we're seeing here. This looks a little different than the command line console we've been playing around with. I should also note that that's why you're seeing the coloration, the line numbers, the file name. It's because I'm doing this visual demonstration in my preferred IDE. That being said, what are comments? Let's throw it out there. Does anybody have a guess or an idea of what comments are?
They're like notes you put in your code so that other people can understand it better.
Exactly. My goodness. Yes, 100% right. Thank you for that. Um, Comments are text you enter in your code that are not compiled or interpreted. Comments are a fickle thing. When I was first getting into programming, I absolutely hated comments. When I got a little more advanced, more adept, I thought they were still a little useless. And now, when I'm writing production content, when I'm doing production level code, I'll be honest, I start with all comments. I mean, it's basically just my verbalization of what I want a particular function or a piece of code to do. And then I just fill in the blanks with logic. And if we were in class, that's pretty much how we would be doing this. When we're getting to projects, I usually, the first assignment is, all right, tell me what we're doing in this code, but I don't want to see your code. I just want all comments. If you came to me like in the hallway, like at school, and you were asking me about something, the first thing I'd say is let's see the comments because the code is useless. You know, almost everything when you're getting started is done in the comments, and then you're just fleshing that out in code. That being said, if you're doing it right, comments will take up two-thirds of your code. Excuse me, two-thirds of your code, while your code itself, as you become more advanced, gets very simplistic and shrinks down in size. So, why would we comment our code? You gave a great explanation because we want people to understand what's going on. So that's the first thing. We're explaining what we're doing in the code. More often than not, there's two reasons. You're explaining it to yourself, well, your future self, or you're explaining it to somebody else who will be looking at your code later. I will say 100 times out of 100 times, I have written a piece of code. I thought it was super elegant, super snazzy, really well done. And then I came back 2 months later and I was like, oh, I was so impressed with this. I'll never forget what's going on here. I came back 2 months later and I had no idea what was going on. I went back from scratch. So there's that. Another reason we comment our code is comments can be used to make the code more readable. So here, I'm always starting with an author block saying, hey, this is what the, the code is going to do. This particular code that you're looking at is a web server I've been working on. It was originally made by this individual. I'm forking it for my purposes. Everything has its little place. This is where I establish my variables, so I know exactly where to look for certain things. Comments can also make your code more readable when you start to stamp them, kind of give them indexes. I know if I press find in my IDE and I look for colon imports, I'm always going to find out where I'm pulling resources from other projects. Um, so that's another reason to comment. Also, when you're debugging code, and we haven't really worked on a project yet, but we'll be completely forthright, 90% of your time is debugging code, basically trying to figure out what went wrong, while only 10% of your time is comment or is actually coding. Um, you can use comments as a tool to cut out certain blocks of code without deleting it. For example, here I was establishing that the host is equal to a term called localhost. Well, I later on decided that's not what I really need, but I wanted to revisit that in case that was the right path. So I just commented that block of code out, and it doesn't get executed. So those are the three reasons why you would comment code. Explain what you're doing, either to others or most importantly yourself. to make the code more readable, and so that you can use it as a tool for debugging or for controlling your code without actually having to make significant changes and deleting things. Does this make sense, guys? There's going to be an
Yeah,
assignment.
makes sense.
Great, excellent, thank you.
Yes.
We're going to have an assignment when we get into our first actual project, and I'm going to give you a template for a comment block, and essentially all your projects will start with comment blocks. And I want you to get used to and comfortable kind of reproducing it. You know, like basically just talking. It's almost like journaling until you start coding. I need to take in a number from a user. I need this number to be multiplied by 2. If the number is divisible by 2 and is even, I want to spit something back to the user. Like, you're just kind of conversational, to be honest, as as silly as that seems. And then you start fleshing it out and filling it in with code after the fact. So that's it. I think this is a great distinguishing practice between abysmal coders and great coders is their ability to comment. All right. Oh, I should probably put the rationale on how you actually comment. Excuse me. So you'll see here that a hash symbol or an octothorpe, however you refer to it, will comment out a line of code. We haven't really seen that because we're doing line by line in the interpreter, but when we start creating code blocks and files, you can comment a line of code out with a hash symbol. You'll note that anything after the hashtag is commented out. You can see that because it's green here, and it won't be read by the interpreter. So you can see here I've done a command called import socket, and then I've put a hashtag here, put a pound sign. Everything after that is ignored. This actual import socket command is still being read by the interpreter. Another, let's see, way to do multiple lines of comments is to use 3 apostrophes or 3 quotes in a row, and that will, it's called a string comment, and that will comment out as many lines until you enclose it with another set of 3 apostrophes or 3 quotes. And those are, that's how you comment in Python. Pretty simple. Hashtag to comment out a line, anything after the hashtag, and then if you want to do multiple lines, just do 3 quotes or 3 apostrophes. Any questions on that? Okay, you won't see the feedback from the command line interpreter. It's not until we start getting into IDEs where you start getting this colorful response feedback to color up your document to kind of give you a clue on where your comments actually exist. It just looks like regular white text in the interface until then. Okay. All right, so now that we're talking about multiple line comments and 3 apostrophes in a row, fantastic. Um, do you guys have your command lines open? I should have probably prefaced with that. Let's start our terminals if you're in Linux or Mac, or your command prompt if you're in Windows, and then we're going to start Python up, and we're going to do a little experiment together. And we're going to attempt a multi-line string. So I'm going to pull mine up as well. Try to make my font supersized for you guys. All right. Is anybody not ready with the command prompt yet, or in the Python interpreter? Just to give you a quick reminder, if you're in Windows, just type in Python. If you're in Linux or Mac, you just type in Python. You hit enter, when you see the three chevrons, you'll know that you're actually in your interpreter. Okay, I'm going to assume everybody's in their command, in their Python interpreter. If not, you just need some time to catch up. That's okay. We're going to go real slow, and you'll reach us sooner than later, I'm sure. If you need me to hold up, though, I definitely will. All right. So I want to attempt a multi-line string um, and see how the interpreter responds. So we can do like we normally do when we're creating a variable. Um, let's see. Somebody give me a variable name, a legal variable name.
Score.
Score. I like it. Excellent. Score is equal to. All right. So the plan is, according to this, I want to write hi there. I want to do a carriage return. Right? How are you? Because I'd like the the string to be read back to the user in 2 lines. All right. So are you guys following along with me? Let's give it a shot. We're going to do synchronized carriage returns. Are you ready? 3, 2, 1, and it blew up. All right. Did everybody get a similar error?
Yes.
Excellent. That's good actually. So there's a lot of information to be gleaned here, so we can kind of look at two facets at once. First thing is we know we got an error, and obviously not what we expected if we wanted to have a multi-line comment, or excuse me, a multi-line string come out. But there's a lot of clues if we want to be really good researchers on how to fix this problem. So let's take a look really quick. Let's go back, and we said score is equal to hi there. So we assigned a variable with some value. We attempted to do a carriage return. And then we see this thing that says file std in. Um, you don't need to know this, but this is short for standard input. And when you do the print statement, that's what's known as standard output. So it's telling us that we're having an issue with our standard input stream, and it's at line 1. But the Python interpreter is so clever and so helpful that not only is it saying in line 1, which most programming language like debugging tools do, it tries to give us its best guess on exactly where we screwed the pooch. So let's take a gander. Let's see what it's got so far. This is what's actually in the standard input feed in that stream. Score, so far so good. The assignment operator, which is an equal symbol. We've got our opening quote, hi there, and then you see nothing. But check this guy out there. That upward caret, it's the upward caret that's above the 6 key on the keyboard. That's the Python interpreter's way of saying, I expected something legal and I got something not legal. So I don't know if you remember in an earlier lecture, I said Python is unique because other programming languages they use a terminating character, like a semicolon when you're done with the line. But Python doesn't use a terminating character. Does anybody remember what's considered the terminating character or the terminating um, factor for a line of code in Python?
Return.
Exactly, a return. So our attempt to make a 2-line string was basically giving us an error because it's saying you just gave me something illegal. There's something either missing or there's something there that shouldn't be there. And this right here after the word there is where it should be. And then we go further and it says the error the type that we have is a syntax error. That seems pretty reasonable. And it's got this funky EOL, which means end of line while scanning string literal. That sounds a little complicated, but when you start to understand the way that the Python interpreter starts to process the information we're giving it, and we know that there's no execution symbol, there's no terminating symbol, the end of the line is a terminating symbol. Well, that makes sense. That's the Python interpreter's way of saying, hey, you either should have closed out the quotes or you returned before you were supposed to. So now we're starting to understand that it's kind of gobbledygook in the beginning. When you start using your programming brain, it makes a little bit of sense. So let's go past this. There we go. And I've got the exact same error as you. So how do we tell Python that we want a string to extend beyond the end of line? How we want the standard input stream to ignore a carriage return? It's very similar, actually, to the way we use a multi-line comment. In fact, it's the exact same. The only difference between a multi-line comment and a multi-line string is that the string is assigned to a variable. Does that make sense? It's kind of quirky, it's kind of weird, but also if you think about it, super simple. Python is great on trying not to make you remember more than you need to. And if you think about it, it's really elegant. You should be using comments anyway. It's the same mechanism, we're just not saving the data. So I want you guys, let's regroup and let's try to do a multi-line string. Let me pull my Python command prompt up. All right, guys. Have you guys attempted this yet? Doing a multi-line string? Let me hear your thoughts on what you're seeing. I'm going to point out some irregularities.
Right.
What was that, Hoshan? I'm listening, bud. Sorry.
No, I was trying to multi-line comment, no, not the string, but it said hi there, and there was a slash, and how are you? It came in differently, but that was a comment. It wasn't
Oh, okay.
a string. A string.
Right. So
Sorry.
if you assign it to a variable
Yeah.
and you do the same process, three quotes or three apostrophes, you can see that as we start the the data stream that's going into this variable with three quotes, our next line has an ellipses before it. That's essentially Python interpreter's way of saying we're kind of ignoring the rules right now for what line delimiting is. As long as you see these three ellipses, you're okay. So if I didn't put these three apostrophes here, I can essentially make near infinite numbers of lines beyond this. But I'm going to close this up because the Python interpreter is now waiting for a valid closing string, and that valid closing string will be the matching three apostrophes. So if I do this, and then I ask it to spit back score, okay, so Hoshang, you were right. I see line 1, and then I see dash n line 2. Let me see if I can make this. There we go. So if I print it, I see line 1, and then I see a carriage return in line 2. This slash n is what's called a new line. It's a new line symbol. And this is basically taking multiple lines of code and putting in one seamless pipeline, one seamless stream, and it's escaping the carriage return. So this would be anything with a forward slash is called an escape character. So the slash n is a symbol, as a representation of a carriage return of a new line. So great observation. That's exactly right. Any questions about this? Okay. What I want you guys to take away from, obviously, three apostrophes or three sets of quotes starts by overriding the end of line, that carriage return mechanism. But when that happens, you're going to see these ellipses. Anytime you see the ellipses, that means the rules are kind of broken. A carriage return is not the executing character um, for for the code, for that piece of code. Okay. I hope that makes sense. If it still doesn't make sense and you kind of have a little delay with it, and then you want to ask some more, we'll do some more examples. All right. So essentially, you've learned multi-line comments and multi-line strings in one go. I hope you like that. All right. String concatenation, we did a lot of this. Well, I shouldn't say a lot. We did a little bit of this last week. I'm going to ask you, how much of this you remember? So remember, we can't add an integer in a string. We can add a string in a string, and that process is called concatenation. So of these options, what is the result if I were to print word1 plus word2? Anybody shout it out. And I'm going to get some tea. We'll go A, B, or C, or D. Is word1 going to stay true? Is word2 going to override word1? Are the integers going to add together? Or are we going to get the summation, the concatenation of word1 and word2?
D.
E.
D. D is actually extremely close. It was a trick question. You're actually going to get the concatenation with no space in between. So as close as you possibly could have gotten with the trick question. And that's only to say, I do this exercise because string interpretation is literal. So the concatenation of strings is also very literal. An empty string would be quotes with a space in between, and I almost said, I need to get in my languages straight. I almost said the Java interpreter. The Python interpreter sees a space, the absence of a character, as a character itself. So sometimes you'll see that as an empty string. So if we were to take this same process, print word1 plus word2, and we were to just change it around so there were variables. Word1 is equal to A, word2 is equal to B, and we added A plus B, we would still get word1 concatenation word2 with no space in between. Your mind would be blown how many pro programmers still miss the empty string. I just want to make you aware of this. If you wanted to achieve a space between word1 and word2, like answer D here, there are a few ways to do it, of course. One would be to make word1 and then space and then a quote, because that empty character is still part of the string sequence. And then you could just do plus word2. Alternatively, you could do the exact opposite. Word1, tight quotes, plus quote space, and then word2. Oops, I forgot. Look at me, I forgot apostrophes here. Shame on me. Bad lecture, bad lecture. And then something you'll see often, probably more often than we should, is multiple concatenation. So essentially taking the pipeline of the string and saying word1 plus an empty character set or an empty character string plus and then the other word. These are all valid. I just wanted to show you how string concatenation works. Extremely literal, as only computers could be. Any questions on that? Just a slight segue back to concatenation. Um, and then you might, oh, good point, there might be a quiz question asking if string interpretation is literal or non-literal. The answer, of course, would be that it is indeed literal. Literal meaning anything you type is what you get, nothing more, nothing less. Okay. All right. Let's see, what time is it? 7:42. We've got plenty of time. Now we're starting to get into the good stuff. This seems fundamental and basic, but these are going to be tenets that are foundational to almost every programming language, and I'm excited to get into this finally. So we're going to be talking about an interesting concept, and I need to try to put on your most accepting brain here and think about this for a second. Strings, which are a stream of characters, right? Stream of words, are seen as, in most programming languages, I'll say most modern and relevant programming languages, as collections, more specifically as arrays. I say the term arrays, it's more common in other programming languages, but that's basically saying a collection of items with an index. So when we see a string as being, hey there, gang, with an exclamation point, it's actually a little more than that. There's a little more going on behind the scenes. Did I lose anybody yet? Possibly. I think maybe an illustration might make it a little more easy to digest. So here's what we wrote. And remember, we just talked about empty strings. A space is actually a character. So we wrote, hey there, gang. We actually put down 15 characters, a 15 character sequence, a stream of 15 symbols. But when the computer is parsing and interpreting something, it's looking at our information, our data, bit by bit, symbol by symbol. So starting at the value 0, this string is actually a collection, an array of letters, and they just happen to go in a specific order. When we're talking about the world of programming, we always start with 0. So you can think of all strings as being a list or an array of many strings. Is this making sense? So this is kind of an obscure concept to think about the words and the lines of code that we use as being just linked like lists of items, of symbols. But this is how the computer is looking at this string that we wrote, hey there, gang. It's looking at it like this. Okay, so if we have a string that isn't really a string, it's actually an array, there's some very cool implications and very powerful methodologies that we can use to play around with this. And this is what I want you guys to take from today. Okay, if a string is actually like more atomic units and we're programming, we've got the power, we can do some interesting things. So how do we access this? All right, let's take a look. Can we get our interpreters out? And I want you guys to create a variable, call it whatever, and let's use the same string. Hey there, gang. Capital H, spaces in between each word, and then an exclamation point. All right. I'm going to assume that everybody's at least somewhat there. So let's push forward a little bit. We can use the index. That's basically the number, right? The number of characters in the value to access these more atomic parts of our string. And when we have the power to take a string and look at it at its indices, its very foundational atomic parts, that we can do really cool things. We can iterate through strings. We can take sections out of strings. We could replace values. We could switch them and randomize them. We can do pretty much anything that you can think of, any bitwise operation. Now that we're starting to look at the process of a string not being this huge block, but more finite individual components that we put together. So now we're starting to look at these things like a computer does. So let's see how we do this. All right, so using the index in the syntax, right, we can use the brackets, that's the square brackets that are to the left of the P on your keyboard. They're below the curly braces. This, and remember I said Python is super great. Well, most programming languages use this kind of convention, are great at not making you learn too much. Because if you can learn this, then you've got lists in the bag. So let's take a look. We're going to take the most atomic section of this string that we possibly could. So here, right here in the command line, I put a string, that's the variable I named it, and then open bracket, the 0, and the close bracket. Go ahead and give it a shot, guys. All right, throw it back to me. Everybody, all together, what do we get?
Capital H.
Capital H. We got the first unit of that data stream. It sounds, I don't know, not impressive, but when you think about the power you can wield when you learn a few more commands, you have a few more tools, this is the start of something big. So I hope you guys start to see this pretty soon. All right, so we just took a string that we basically handed the computer as an amalgam. It had to dissect this so that it could store this via bitwise operation at a very low hardware level. And now we're able to recall it and say, hey, I've got the power to do things on the individual components of what I handed you. So, for instance, like we just saw, we can look at the very first character in that string. But we can do some more because Python's got a bunch of cool tools built in. So let's take a look at this. If you take that same bracket notation and then you start to throw in more parameters, like more guidelines on how you want it to operate, you can start to do really cool things. Great example. So we took the same string and I said 6:9. What I'm telling it is I want you to start looking at this grouping, right? This object, this thing, but starting at its sixth element up to, but not including its ninth element, and then give it back to me. So we're basically taking this entire string, we're chopping it up into its most basic values, and then we're saying, I can take any piece of this that I want to. What's cool about this, and we haven't gotten there yet, is when we start to look at logic, starting to throw logic into this, we can go through vast amounts of data. Remember, data is uninformed. It's not information. It's not connected. We can take vast amounts of data that are coming through our systems that we're programming applications for, and we can look through this entire like matrix of information and pull out very specific things, or if certain factors line up in the way we want or certain parameters exist in the way we want to, we can start pulling and playing around and modifying with data at a very low level. It's going to get really cool here. So I've got a couple other ideas or a couple other concepts I want you to play around with. I want let's see, we've got how many people we have right now. Okay, let's see. Aditya, can you do, let's see, do string 10 colon? And then
Yep.
Hashang, can you do your whatever your variable name is, colon, and then 11? And then Christian, can you do the variable and the brackets? It's just going to be -4. Go ahead, spit that back to me, and then let's see. Let's talk through this.
I
Go ahead.
got A.
You got A. All right.
I got gang exclamation mark.
Okay, hold on. So you had, wait, who
10
had
colon.
10 colon? All right, excellent. You got gang exclamation point. So I, let's talk through this one. The colon is that parser for the next part of the parameter. But if you leave that second parameter open, you're basically saying start at character 10, give me everything from character 10 until the end of the string, the end of this glob that we have. So that's exactly what that does. Who had colon 11? Hoshang, was that you?
Sorry, I was on mute. I got hey there, G.
Hey there, G. Okay,
Yeah, I
excellent.
put in like a 0:11.
Perfect. So even if you didn't put a zero, if you just put the colon, that's basically saying start, it's going to give everything from the endpoint, the final parameter being the index 11, give you everything preceding that. And then Christian, you had a string minus 4. I think.
Yes.
Okay. So a negative index is really interesting too. When you start to look at the indexes from 0 through, whatever the index length is, that's one thing. But when you start to throw negatives in there, that's when we start working from the back end towards the front. It's just another way to give you another tool to play through some of these strings and how to work with some of their atomic parts. So we start with the last character, the last symbol being -1, -2, -3, and you should have you said an A, right? -4. So these are just some of the more minor built-in tools that we can do when we're starting to play with strings. It's kind of funky. It might not make sense, but what I really want you to glean from all of this, besides playing around and be able to see that you can slice, right? This is what we call slicing, taking subsections of a string out, is that a string is seen differently to the interpreter than what maybe our intention was when we gave it to it or when we piped data into our program. So now I ask you to try to change your frame of mind and start thinking about strings in this way. Think more like the computer, and it's going to give you a lot more mileage when you're trying to debug and figure out the way things work or come up with clever solutions. So, there are a lot of people who don't recognize that a string is actually an array at its core. And now you have the tools to do exactly that. And we're going to be playing with a lot more logic, filtering tools, and loops to go through and do more activities with strings or other arrays or collections too. That was kind of a lot, but any questions on that right there? Okay. I get it. A lot of this is going to be kind of like a time delayed mental bomb, and then like 4 hours later, you're gonna be like, whoa, 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 hold on. Let me go back. What? A string is an array? So we will be revisiting this regularly, and a lot of our projects will revolve around iterating or moving through these bigger chunks into their more atomic parts. All right. Oh, good to note. Slicing does not modify the original string. So if you were to type in a string again, or whatever your variable name is, you would get your original value. It doesn't do anything to it. All right, I want to try to burn through this a little bit, but I want to honor the content. I'm so sorry that we took so long. It's 7:55. Let's get going here. All right, string formatting, because I need you to recognize how absolutely shitty string formatting used to be in Python and how blessed we are now with the tools that we have. But before we do that, I want to talk about a little bit about how the interpreter sees things. We're starting to see how strings are kind of viewed as arrays. Now I want you to see peel back the layers a little bit on how the interpreter does what it does. So let's consider this. Strings can have variables embedded in them for use. We might not have directly said this, but we've been dancing around it, right? So here we're taking the variable name and we're attaching Weird Al Yankovic as a value to it. Okay, that's pretty common fare. And then what we're doing here is we're creating another variable called greeting, and we're taking a couple of concepts that we were working with, and now we're like pushing them together. We're taking a string, my name is, and then we're concatenating a variable. So we're seeing this Weird Al Yankovic name is assigned to this variable, and now we're adding this or having this as an addendum to the original string. And then if we were to print the greeting, which is the equivalent of the string my name is, there's a space here. We're honoring that empty character set, plus a variable that we've already established. Surprisingly enough, our greeting that we output when we print is my name is Weird Al Yankovic. It's the entirety of it. It's this string plus what we've already saved here. I want to dig into this a little bit to help you guys kind of understand some of the coolness of what's going on here. So first thing, the interpreter, when it's looking through your code, it's going top to bottom, left to right. Edge cases aside, that's pretty much what's going on. We're going from line 1 and we're going each character. Remember when we saw that debugging process and had that caret? That's because that's where it was going, character 0, character 1, character 2, something's missing in character 4 that should have been there, but it's not. So that's how the interpreter knows what's going on. It's going all the way down, and then it's going, from left to right. Standard, like American English practices. So, and that's how it evaluates the syntax. So if we're going through this really quickly, we're saying, okay, name. So far, nothing going crazy here. Syntax seems okay. Equal, there's an operator. As soon as this happens, the interpreter's already going to work, and it's creating a variable tag in what's called namespace. It's the space where variables are available. And then it's assigning or it's preparing, to assign a value to it. And then here's what's going. It's going each letter, starting with the capital W. Okay, going through one at a time. W, that's okay, that's okay, that's okay. Essentially, all it's really looking for is this double quote to close off the string. It goes empty character space, no big deal. Hey, here's a quote, but you know what? Apostrophes are completely valid. It's not looking for an apostrophe, it's looking for a actual quote. So we'll allow it. That's not the end of it. We're going to keep going, all the way to the end until it hits this second quote. The second quote here. And once it's got the last closing quote, it packs it in and it assigns that value to this variable. Are we tracking so far? I know I'm talking a little fast because we're at time already. So here, variables can actually contain references to other variables. This is what I want you to gather from this. They're not storing, that greeting is not storing Weird Al Yankovic to its string, to its value here. It's storing a signpost that says, where's the name at? Because if this name were to change somewhere in the code or by some of the processes or mechanisms that our app is performing, greeting is still going to be accurate. It's still going to say whatever the name that we intended it to do. So I wanted to take a little bit of a timeout and let you guys know that not only can you put a variable reference with a variable, you can concatenate them and you can print them out to standard output, but the process that the interpreter goes through, top to bottom, left to right, and it's looking to make sure whatever the next symbol is a valid symbol. And that's how the interpreter works. Any questions on that? Excellent. So if you were to have a quick quiz question that said, the interpreter is Evaluating your code from bottom to top, true or false. What would the answer be? False, yeah.
False.
Excellent, thank you. All right, we're at time. I got two more slides. I'm going to try and burn through this. I want to show you an old standard for which we had to do string formatting, which is essentially a nice way of saying putting variables into strings or into output or um, into display. So before, it used to be like, here's the name variable, we're assigning a value. Here's the greeting, and and the value of this is my name is, and they call these mustaches or curly braces, and all that is saying this is a placeholder for a variable. That seems pretty simple. That's not too bad. But here's where things get really crappy. It used to be if we wanted to print the same thing that we're printing here, my name is Weird Al Yankovic, we'd have to say print greeting. So that's cool. That's the variable that we said. But then there was a method that we had to throw here, and it was a method that was called format, and it said pick the first placeholder you have and put the name, you put whatever value you want in it. That seems like it's not a big deal and it's not time consuming, but I swear it is so crappy because when you get bigger, more complex code, and maybe you have multiple different variables in there, your simple variable with variables that references attached to them would look like this. Order is equal to order of placeholder, placeholder, some more text, placeholder. And then when you wanted to output that, it was print your order, this variable, but then format it. And then drop in everything for the placeholders in the order you wanted them. You could also do them out of order, but it was even more work. So then, after all of that work, you finally got the output that you were intending. An order of 3 burritos costing $15.75. That was the way we used to do string formatting, or allowing variables to sit within our code and call upon those references. It's a little simpler now. Now we have what's called F strings, are more commonly known as template literals. So this is equally as complex. I want you to note a couple things. We're going to go through this a lot. In fact, all of your strings with variables in this course will be using F strings. I will not make you do the old way because it's terrible. Here's the rules. As long as the variables have been declared and they have the values, sweet. All you need to do in order to pull that variable, those bits of data into your string, all you have to do is put an F before the quote. The F is short for format, and the quote means strings. So it still harkens back to the old days of formatting strings. And then any place where you would have your variable or your value go in, you still use curly braces and then you put the variable name directly in it. We don't need an additional line of code and this funky format method in order to do this, to create this output. I know this may seem like it's going a little fast. I just wanted to make you aware of how we can insert variables into output and seamlessly, and explain how it used to be a really shitty process and now it might be a little confusing, but it's much more seamless, it's much cleaner, much more elegant. All you literally need to do is put a placeholder with the tag, the name of the variable that you're looking for, and as long as there's an F before the quote, you're good. Does this kind of make sense? I know it's a lot,
Can you
guys.
only use the F string in the print method, or can you use it in a variable declaration as well? If I wanted to like make a variable that had what was inside that print method right now? Could I do that? Could I make a variable that says like string a string equals and then f quotes in order of and then etc.
Yeah, you could. You could.
Okay.
Yeah. Almost done. String methods. This is going to be a lot to bite off, but we're just going to get you kind of immersed with the concept that methods exist, and we'll talk about this, and then we'll be done for the evening, and I'll answer any other questions. Really quickly, sorry. Any other questions before we go back? Or before we move on? All right, from this slide, F strings are a thing. They're freaking sweet. They're so much better, cleaner, more easier to work with than the previous format strings. Um, and it's basically a quality of life feature that was put in Python 3.7. So I hope you guys enjoy it because it was so much more difficult to do to create output or to dynamically put variables within strings before. Additionally, um, it was a whole nother Oprah to be able to add integers into your strings before f strings because as you can see we literally just put a placeholder for the integer and then it's there. Cool. Okie dokie. All right, again, question crops up, let me know. We'll go back. Okay, string methods. Um, do you remember last week we talked about the concept of functions? I think we even built a really simple kind of useless function. So functions are pre-packaged lines of code, named lines of code that are reusable. So functions are fantastic. They're integral to the coding process, and all modern languages have them. But there's a distinguishing difference between a function, which is kind of standalone, right? We use that um, to perform a process that has multiple mechanisms within it. We can call it, we can pass things to it. There's another flip side of this coin. If there's what's called, and we're going to get into this in detail, so if you don't understand it, but if there's what's called an object or something that's more complex, and that this object can perform things, it can do things, it's got verbs, right? Then they're no longer functions because functions are kind of detached. They're on their own. Either we've created them or somebody else has created them and we can use them by calling them. But when we're using quote unquote functions that belong to a more complex entity, it's it's possessed by that entity, it's built from that entity or for that entity, then that's called a method. You're going to hear or see if you're in the programming forums a lot of buzzwords getting thrown around. Methods versus functions. Functions are kind of insular. They're isolated. They're built with pre like pre-built mechanisms. You can pass them parameters, you can pass them data. They can work on it and spit something back out. Methods do the same thing, but they're not insular. They're attached to something. I don't know if you remember in previous lectures, we did the type method to see if the type of a string, what it showed. And if you recall, it didn't just say that the type was a string or the type was an int or the type was float. It said it was a type class string or class int. It's The concept, the idea of a string or an integer is it's a larger, more complicated than it appears to be that primitive value. The mechanisms that are required to make that be passable to standard output or standard input, they're, for lack of better words, and we're going to get into this in later detail, everything in Python is an object. These objects, like a string, which simple is a simple thing, but it's not. It's built intentionally to appear simple but have mechanisms behind it. They have functions attached to them, and those functions are called methods. When they're no longer aside and separate, when they're a part of the object, they're called methods. And that's like saying this thing, whatever this thing is, and in regards to strings, we're calling it a string. This string can do something. That doing part is not a function, it's a method. It's so hard for me to explain this without us jumping headlong into objects, but we're a ways away from objects, and I just kind of want to scratch the surface without scaring you too much. Does this semi make sense? Functions are kind of by themselves, methods are attached to something. Does that, does that kind of make sense to you guys?
Yep.
Okay, great.
It's
I
kind of similar to Java, I feel like.
Yes, yes, exactly. I think it's going to be a universal concept. When you're talking about functions versus methods, they're the same in almost all object-oriented languages. Functions are kind of standalone items. Methods are attached to something. And I bring this up because something interesting to note. A string, all strings, um, which are part of the string object in Python, we'll get into what that means later, has its own set of methods, its own little toolbox that you can use to do things with it, to manipulate it, to change it, to kind of mold it. And that's the whole point of this slide. I don't want you to feel like you have to understand this. I just want you to be aware that strings have verbs, they have tools attached to them, and we call these string methods. So in this really brief example, God, I gotta burn. Sorry guys, we gotta get through this. I've created a variable called a, and I've assigned it the value, hey there gang. It's a string, but it's actually a string object. And we can do some very interesting things with this string object's methods, with its verbs, with its built-in toolkit. And I just wanted to share a few of them with you so you can start to see the power because, like strings, everything in Python is an object and everything has its own unique set of cool tools to help manipulate it. So we'll go through some of these really quickly, and there are a ton of string methods, but here's some interesting ones. So the way you invoke or you call a string method is, if you recall, a method has open parentheses and close parentheses after it, and then whatever the name of the method is. That's like saying, use your verb, use your tool. In this case, the string object has a tool called title. When you use the title method on a string, it doesn't matter what string it is, any string in existence in your application, what it does is it makes the first letter of each word capitalized. It seems kind of silly, maybe even pointless, but somewhere down the line, somebody was like, I need to be able to capitalize the first letter of each word. I'm going to build a tool for this. And this tool is so fundamental, I'm attaching it to all strings that will ever be in existence in Python. Does that make sense?
Yep.
Likewise, other core programmers, or who maybe even had these tools in other languages, were like, I need a tool for a string that changes everything to uppercase. I no fuss, no muss. I don't want to go through and like do anything or do work any code. I don't want to create it. I need this to be an integral part of verb that's permanently attached to the string object. So if you take your variable a, which is a string, hey there, and you call the upper method, then it's going to take everything that's in a and it's going to make it all uppercase. Conversely, they do the same thing. They're like, all right, I've got this great method, this really cool tool that I need for my strings. I need to be able to do this to make everything lowercase. Somewhere down, somebody down the line needed this tool and they needed to be core and attached to all string objects. And lo and behold, there it is, lower. There's also more, I don't want to say more functional, but more interesting, complex methods. So here's a really cool one. This one's called replace. And this method, like the function we saw last week, takes parameters. It takes bits of information, additional information. It actually takes two, this first parameter and the second parameter. And the whole tool, this whole replace tool, this whole verb, its only job is to look through your string because it's an array and it can go through one at a time. It's all coming together now, right? Look through one at a time, and any instance of a lowercase e, whatever you put in as your first parameter, change it to a lowercase o. And that's the entire sole existence, its rationale, its raison d'etre. The whole reason that this tool exists is I need to be able to go through a string. I don't care how big it is, how long it is, how complex it is. I need to be able to take whatever this letter is that I give you and turn it into something else. Make this core, make this a functional, foundational part of the string object. And here are the results. If I took hey there gang, and then I used the replace method, I gave it an E and an O. I'm saying find all E's in hey there gang and change them to O's. Hoy thorough gang. That's all it does. So I don't want you to memorize these. We're going to go through we're going to take some time to explore some of these really cool methods. But I want you to understand that these methods are attached to all strings because all strings are objects. So they're attached to this root object, this root concept. And we can call them. And they all do something different and they're all named and some of them take parameters and some of them do some really unique, really wild, really beautiful things to make whatever we're trying to accomplish with our code possible. All right, I'm going to show you two more really quick methods. Open it for questions and we'll call it. I am so sorry for keeping you guys. Okay, there's a really interesting one called split strings. Somebody at one point had to do this by hand and they're like, never again. I'm building a function. Nope, no longer function. This is going to be core to the string object. It's now a method. It's now a permanent verb, a permanent tool. And the split takes one parameter and it will take any string that you have and whenever it finds whatever you gave it as a parameter, it will then split the string up so it's multiple strings. It's now actually an array. It's now a collection. So here I put Veni, Vedi, Vici, and Vedi is completely incorrect, but that's okay. But it's separated by comments. I use the split method, and told it the comma is the functional character, the symbol that you're looking for. When you see that, that's the end, and you're now splitting it. And it created a list. It created a collection of these texts, and instead of it being one string, it is now a list. Likewise, because a empty character or a space, if you will, is considered, I'm trying to bring it all together for you guys, is considered a character or symbol. I'm saying anytime I see, hey there gang, if I see a space come across the interpreter, that's where we split it. I want you to chop it there and throw it in this list. So there we go. Instead of hey there gang as a string, now there's a list with three words in it. Hey, there, and gang. Okay.
Would
I,
that be considered like, since the strings are lists themselves, would that be like a list inside of a list?
exactly. Another way of calling that, if you're coming from other languages, would be a multi-dimensional array. Because you could say, I want item 1 from this list, and item 1 would be hey. But if you said, I want item 0 from item 1 in the list, it would throw back H. It's looking at the first item, which is this word, and then you're looking at the first item, which is the first, I say first item, the first index, and that index is 0, 1, 2. So yeah, excellent. Very, very astute observation. 100% correct, dude. That's your question?
Yep. So like if I wanted to call that, would I call it like a two-dimensional array?
Exactly.
Like 1, 0?
Two sets of brackets. So one set of
Okay.
bracket would be the first index set, and the second would be the next index set. So guys, what we're talking about is uh, this string hey there has been set up into, and we said hey there has indexes, right? Well, what we did was we took this and we broke it up. Anywhere where there's a space is where a new list item begins. So we created a list with the contents hey, there, and gang. Three words in that collection. Index 0 of this collection would be hey. Index 1 of that collection would be there. Index 2 of that collection would be gang. But if you wanted to look at the first index of the first index, it's called a multi-dimensional array. We're basically saying, I want to look at the first index, cool. And now this is a list by itself. And I want to look at the first index of this thing, and that would be the H, or the second index, or the third index. It's a little mind blowing. You kind of gotta go into a little Matrix mode there, a little Doctor Strange, the world folding in on itself. But I swear, these things get easier to comprehend and think about in these terms the more you play around with it. And we will be playing around with some multi-dimensional arrays and having some fun and just letting our brains steam for a little bit. Excellent, really, really great observation there. Thank you for bringing that up. I feel incredibly guilty for keeping you 25 minutes overtime, but there was a lot of stuff. And this stuff, this foundational stuff, is going to be prevalent in any major programming language, any modern language. So I thought it was really important. Even if you don't understand the mechanism, the syntax, just the concepts that are behind it, really, really core. And it also is it's kind of like the gateway in changing your thought. I think one of the things that most programmers find when they're going from being a beginning programmer to an avid programmer is that their problem solving approach gets drastically and radically changed. I would say for the better, because they're starting to look at things in these different conceptual realities. So I digress. Enough of the philosophy of programming. I can't speak highly enough about it. But any questions that you have, I'm here for you. Okay. Sorry if I scared you off. I swear it's not that scary. I just want to glass the surface. I'm gonna give you a whole lot of information, and then we're gonna go back and we're gonna peel the layers little by little over the next couple weeks here. We did not have enough time to get into quiz review, so I guess we're going to do the entire rest of a class to solid, and I am going to give a quick review of things that we should know. You'll know after this quiz that I'm pretty, I would say, lenient. It's more important to me that you're here to understand as opposed to here to pass a test. So I will go so far as to tell you, hey, you should know X, and X is in this lecture, slides 2 through 4. I want you to feel comfortable enough though. If you don't get something to bring it up, let me know. Send an email, and then more importantly, inquisitive enough to kind of discover and dive deeper if it sparks your interest. So please let me know if there's any way I can help facilitate that. I'm here for you guys. As you know, my phone number is on the syllabus. You can text me, you can email me, you can call me, and I'm at your disposal.